Welcome to today's webinar, How to Deploy an Artificial Intelligence Solution in a Clinical Setting, Everything You Need to Know. I'm Anna Minihart, I'll be your moderator, and I am here with our speaker today, Liren Zhu. Thank you for being here. Liren is a PhD in biomedical engineering from Washington University in St. Louis, and he is currently the head of engineering at Subtle Medical. Again, thank you for being here. We're excited for today's talk.
Thank you for having me here.
So the growth of AI over the last 5 to 10 years has been exponential, and according to industry experts, there's no sign it's going to slow down, especially in healthcare. According to recent market analysis data, the artificial intelligence industry is expected to balloon from a few billion to more than 60 billion in the next decade. Medical imaging's portion of that could reach up to 19 billion by 2025. The question is, are you ready? Is your organization ready? So Liren, it seems like 5 years ago there wasn't much buzz of AI in the radiology field, but in today's world, it seems like at every industry conference you go to, there are countless sessions on technological advancements in AI and machine learning, and all are influencing really different parts of the radiology workflow. Can you speak to some of these?
So what we're seeing right now is that AI is being applied to almost the entire process of radiology. For example, a common task for radiologists or technologists or any practitioner in this process involves the image acquisition and sometimes enhancement of processing, and then common tasks will be analytics, quantification, and then in the end you have diagnostics, and after diagnostics you go to treatment and a bunch of other stuff that you have to do. So what we're seeing today is a lot of products being developed in the area of the analytics, quantification, and as well as diagnostics. On the other hand, though, I think there's a lot of opportunities in the image acquisition stage of this process. A lot of researchers are working on that. You see less products being released right now, but these researchers and products are focusing on generating high quality images and visualization of these images for later stage to use them. So I want to emphasize that these two types of applications have very different characteristics and concerns when you try to implement them in the clinical settings. For example, on the left, you see in the image acquisition stage, you consider integration, and when you consider that, you're thinking about there's variety in the clinical workflow in a lot of different hospitals. These applications usually requires a lot of connectivity to scanners, PACS, and RIS, whatever you have in the hospitals. There's also security concerns for these applications, but the general principle for these applications is basically you try to minimize access from outside because they don't usually require a lot of user interaction. Speaking of user interaction, you have usability. For these applications, usually you want them to be as simple as possible when you're talking about interacting with users, but also you want them to be effective. On the other hand, if you look at the diagnostic tools based on AI that's being developed right now, you also have integration, you also have connectivity to different systems that's already in place. But on the security side, the concerns are a little bit different. You usually, because you're interacting directly with people, you need a comprehensive record of user access, and you need control. Different users should have different privileges to sensitive data, such as PHI. On the usability side, these tools are user-facing, so they need effective and rich UI and user experience design.
So for those listening in who are looking to implement an AI solution in their hospital or imaging center, in an already complicated IT system, where do you plug in an AI application without disrupting the current workflow?
So as you just said, clinical IT systems are usually quite complex already in today's hospitals. It usually involves a number of different entities, usually the software or services in their network settings. Important players involve scanners, PACS, hospital information system or radiology information systems and viewing clients. A typical workflow would be people acquire images from scanners and then they archive those images or push those images to PACS, which serves sort of like a data center for these clinical images. And these two major systems also take information from RIS or HIS, which a typical use would be RIS or HIS will push prescriptions or other instructions to scanners or PACS. And in the end, you have the doctors, the radiologists will be using viewing clients to pull images from PACS and view them on their specialized viewers on their computers. Sometimes you also have post-processing and visualization workstation sitting right next to scanners to facilitate some of the complex visualization and post-processing tasks. An important fact that we need to consider is that each hospital, each healthcare providers would typically have a unique workflow that's designed based on their needs. And that means their ways of using these systems could be different from each other, sometimes very different from each other. So when you consider an acquisition stage app, usually these apps insert themselves between the scanner and PACS. That's one of the typical way to do this. From the IT's point of view, it could serve almost as a DICOM filter. So in the sense of like you push image to that DICOM node, and after the processing is done, the DICOM node automatically push the processed image to PACS. And almost all the end users don't see its existence from a clinical workflow point of view. And during this processing stage, the vendor could choose to perform de-identification and the re-identification. That way, it enables the vendors to send anonymized images to a trusted public cloud provider to better utilize their computing resources or share their computing resources with other customers to cut down costs. An app may also accept instructions from RIS just as a scanner might accept prescriptions from RIS. That way actually provides the app the ability to customize some of the processing steps and provide a way for radiologists or technologists to customize the instructions to it. The downstream stage will not be affected in this case because the viewers will still pull images from PACS. Sometimes the hospital might want the processed images to push back to be pushed back to scanners, so that the technologist could do some of the quality check before the image is actually archived into the central PACS. So it's very common to implement these apps in this way, illustrated here. So the only change you're seeing at this slide from the previous slide is that the connection from the DICOM node is changed. It's no longer pushing image to PACS, it's pushing back to the scanner. This way you form sort of like a local loop between the scanner and the DICOM node, the vendor's DICOM node. Or sometimes it could be the workstation and the local DICOM node. But in both cases, you basically have a branch out of your clinical network and does not really affect any other things that's happening on that network.
And what about a diagnosis stage AI application?
Right. For a diagnostic app, usually the IT integration would be a little bit more complex than acquisition app. At the current stage, most diagnostic AI apps still need to interact constantly with the radiologist, because at this stage, either both the market and the regulatory bodies don't really buy into the concept that these apps can provide very reliable, very explainable diagnostic endpoints directly to patients. So radiologists still need to approve and review these results being produced. This automatically requires a direct connection between the viewing clients or the software, or either the software or these computers to your app's internal server or cloud server. Typically, data is still is pulled from PACS instead of being pushed directly from scanner. So there's a little bit difference in this mechanism, because if you want to pull data from PACS, you probably want to configure the security like authorization better, and that's a more complex process. You may still want to implement de-identification and re-identification on the app, just to keep the sensitive information within the hospital network, and still keeping the ability to push some of the processing to the cloud platforms where you have better access to computing resources. Also, sometimes the users might want to use the app from an off-site location, such as some radiologists might want to view their images from a home office, or some imaging centers might commission some of the viewing kind of tasks to a contractor, a radiologist contractor. So it's very common for these apps to provide offset connection. So as you see in this diagram, because of that, there's a lot more connection that need to be established, and a lot of more connections going through the hospital firewall. That adds a little bit burden on the IT staff. And also from the app builder's point of view, you need to consider any of these connections need to be very well secured.
So let's talk about efficiency. Most applications require a lot of computing power. What do you need to be able to support this kind of demand?
That's a great question. So typically these AI apps use a type of algorithm called deep learning. And these algorithms are built on the foundation of modern GPUs usually. But recently we have a lot of CPU chips can also support the computation demand of these algorithms. So just to give you an example, we did a little bit a bench test on our own algorithm. For a typical CPU without any optimized framework on top of it, you would get about 100 seconds to process the entire volume in this case. So if you can have access to, say, more recent CPUs and put some optimized frameworks on top of it, you can cut that time down to less than half of the original time. But if you can get modern GPUs, for example, T4, that's an NVIDIA GPU, or a V100, even better, you can get even better performance from the baseline. So the conclusion is basically the access to modern chips, GPUs and CPUs, what have you, is very important to the speed and performance of these algorithms.
So one of the biggest concerns around AI solutions and cloud solutions, especially in a healthcare environment, is security, especially that of protected patient health information. Can you speak to choosing a cloud versus an on-premise solution and how they compare when it comes to efficiency and security?
You're right, the security concerns is one of the biggest challenges to applying AI solutions in a clinical setting, especially for a lot of these AI apps. They need access to modern CPUs and GPUs. And in order to get fast and scalable access to these hardware, you probably want to run them on a cloud setting. However, if you put your app on the cloud, there's additional exposure to cybersecurity risks. On the other hand, if you put your app completely on-prem, you do have better controls of your data security, but not necessarily better security, because you still need to be security aware in order to prevent any kind of attacks. On the flip side, for on-prem solutions, you have potential expensive computing resources that you have to purchase in addition to whatever you have right now. And also it's very slow to scale and very expensive to scale if you want to expand your AI application to more images, more data, more patient. So in our opinion, a hybrid solution provides the benefits from both solutions. So what we propose and what we think is the best practice here is that you have a small instance on-prem sitting within the firewall of the hospitals or imaging center. And that instance, that computer basically just performs the identification and the re-identification and strip the sensitive information from the image data, and then you package the image data, send it to the cloud, and let the cloud handle the heavy lifting of the AI app. In this way, provided that you follow the best practices of security, such as you encrypt all the communications, you encrypt data at rest, both on your on-site instance and in your cloud, you can mitigate most of the security risks and still have access to scalable and recent hardware that's kind of needed in a lot of modern AI applications.
So let's say the IT infrastructure is in place and it's secure. What's the next step in the deployment of a new AI solution?
Right. In terms of deployment, nowadays people actually have multiple different choices, different options. So the traditional, most conventional way to deploy these apps to hospitals is to use hospitals' data centers and existing IT infrastructure. Typically, the way to do that is you are given access to a virtual machine and you have control at the operating system level. The downside of that approach is that it's very hard to get additional computing resources because it typically has to go through a separate IT review process. And the hospital IT department have to double check if there's additional risks in the additional resources that you require. Another route, which is becoming more and more popular, would be putting your app on a public cloud provider. In this way, you will have access to a lot of modern software development tools, particularly DevOps tools, which provide scaling on demand and also monitoring of your service health and analytics features on your service usage. Also, there's access to modern orchestration tools, which handles the provisioning of computing resources automatically. A third, a more recent way to deploy your app would be to use a third-party marketplace. Actually, a lot of traditional IT service providers in the healthcare field, and as well as scanner vendors are rolling out these services right now. In these marketplaces, you have access to a managed hosting service and a managed execution environment, meaning you only provide the algorithm and the code that implement that algorithm. You don't have to worry about the computation environment. You don't have to worry about scaling. Although the downside of that route is that these marketplaces currently have different APIs. So if you are delivering the same algorithm to different marketplaces, there's a lot of additional coding you have to do. So to sum up, basically we have three major options when you're considering about deployments. The most traditional one is to go through hospital data center. You can also use a public cloud. You can use a third-party marketplace. It's sort of like what you would have access to when you want to build a website. You can do your own server. You can do a cloud provider. You can also do a kind of a drag and drop web editor.
Like Wix, GoDaddy.
Yeah, like Wix and GoDaddy. Yeah. So the deployment options are, there are a few different choices, and different routes might have a little bit different characteristics. And from the hospital perspective, these means of deploying AI solutions might affect some of their integration settings, because they might be talking to existing systems in different ways. In the end, the choice of the deployment options will have to be based on the app's, the nature of the app, and particularly based on the needs of the user. And you should always keep in mind the ease to integrate with existing system and security and efficiency trade-off. is still very important when you consider different deployment options.
All very valuable information. Thank you for sharing that level of detail. If you were to give everyone, 3 takeaways from today's talk, what would those be?
So to summarize, I think it's very important to know that there are ways to make AI applications that works well with existing workflow and works well with existing infrastructure in hospital networks. Secondly, cloud deployment options actually gives us easier access to necessary computing resources to run these very demanding deep learning algorithms. And third, I think you can achieve a balance between security and efficiency by carefully designing your software architecture.
Thank you again for your participation to everybody who has joined us today. Thank you again, Liren, for your discussion. To catch all of the webinars that we've recorded here with the Subtle Insights series, you can search Subtle Medical on YouTube and find our YouTube channel. Feel free to subscribe so you don't miss one in the future. We do these webinars about once every month or 2, so stay tuned. There'll be another one coming soon, and we hope you'll join us.